He is the head of Pathology Informatics Division at Henry Ford Health System, and he is going to be talking to us about, and my mind is going blank, project management is what we last talked about.
I hope you weren't changing my talk.
No, I'm not changing your talk, Mark.
I might have one.
I was going to change your bio, though, since somebody didn't send one to me, so.
You asked me for the bio on Thursday after I'd already left. Well, good morning, everybody. How's everybody doing out there? I see most eyes are open. Yeah. All right, I love yeah. Good deal. Well, I have the enviable position to be between you and lunch, which always seems to be my position in life. So I'm gonna delve deep into this, or get going with it anyway. Let me just ask a couple of questions, and I apologize, Alexis. I'm going to go back to the first grade audience response system. Is there anybody in the audience who's actually a professional project manager? Oh dear. Okay, so I'm already in a little bit of trouble. Has anybody actually managed more than 10 projects with more than 100 people? Okay, good. So I'm in safer territory there. Because I'm really stepping into something that I am not an expert at. And I am only an expert at it because I was forced into the role of managing projects and working with project managers to help get projects accomplished. But it's important to realize that this is a formal profession. In fact, if my LIS manager were sitting out here watching me talk about project management, she would probably have a bucket full of tomatoes ready to sling at me, because I am probably her least favorite person when it comes down to project management, because I'm responsible for half the scope creep. And we'll talk a little bit more about what that is. But I think it's really important to realize as we start out that the chief cause of stress is reality. And any project, that's what really gets you and bites you in the butt, because projects are real and nobody really wants to deal with all of the requirements that you have to go through to implement a project. So what I'm going to try to do is really take you through sort of maybe an elementary to high school level approach to project management, using some of the formal terminology that you'll run into as you interact with project managers, because it's important to understand people's lingo. If you don't know the lingo, you're immediately missing, you're left at the doorstep. But then I'm going to kind of segue into some more practical issues that will kind of build upon those concepts and try to interrelate them specifically to implementing a laboratory information system. And while I'm going to focus on an LIS, I think we could probably apply these same principles to almost any project that we're thinking about. We'll talk about the phases of project management life cycle, how we apply this to system selection and implementation, some tips that I've learned around project team creation, as well as some practical concerns for implementing projects in the real world. So just to kick it off here, the introduction to project management, I think it's important first of all to know what a project is, okay? This sounds sophomoric, but it's important to recognize that a project is a temporary thing. If the project goes on forever, it's not a project. I don't know what it is. It's probably like being caught in one of Dante's levels of hell or something. Okay? So a project is supposed to begin and end. It's a temporary thing. It doesn't go on forever. I try to explain this to members of my teams. They don't seem to understand this. You want to accomplish something. You want to use your resources wisely, and what we're going to talk about is really implementing software projects. But we could be talking about building bridges or skyscrapers or interstate systems. They're very simple. When you build a skyscraper, you don't build the skyscraper forever. At some point, you operate it. It's also important, as I alluded to earlier, that project management is really a formal science. There are people who do this as professionals for a living, go to school, train to be project managers, and so they know a lot more about this than I do, certainly, and probably more than most of us sitting in the audience that are going to get asked to manage project managers. So look for people to get on your team who have had training in project management, and it will pay off in spades for you. I think it's also important to realize that project management is not a software program. It is not sticking things into Microsoft Project and making it all look pretty with lines that connect to one another. It's actually something that people do. Software helps you, but people implement projects, not software. And it's also more than a plan. So the project plan is only one part of managing an actual project. So if we think about it, what is it we're managing? We're managing the scope of a project, the time that it's going to take to do it, the money. That's the one that always seems to get us if we're not careful. Obviously, you want to have a good project, so the quality of the project. You need to manage the communications around a project, the human resources, the materials and services that you're going to use in a project. And the term materials may seem a little foreign here, but what we're really referring to, in our case, is probably the hardware and software that we're going to use to actually run our laboratory information system. These are our materials in our IT projects. Risk mitigation and awareness is an important part of project management. And then ultimately, what it really comes down to is coordinating all of these teams and making sure we've got good communication across these teams. This is the project management outline that I have used for years as my sort of mental checklist to going through project management. And I've noticed as I began to educate myself more formally so that I could then educate you all a little bit more formally, that I actually had many of the appropriate components of project management in this list. So you might be able to take this list home with you and use it as a way to begin to frame a project that you might want to implement. But we can actually take this list and turn it into something that is formally recognized as the project management life cycle. The life cycle begins with what we call initiation, in other words, starting the project. This is typically a customer-driven, leadership-approved desire to have something created. Planning process for that particular project, including financing and getting your resources together. The execution phase of the project, monitoring and controlling the implementation, and it's an iterative effort, actually, between planning, execution, and initiation, isn't it? Because each of these things ultimately inform one another. As you begin initiating it and start to plan, you're going to learn more about what you need to do in terms of the project life cycle and how you actually need to finance and resource your project. And then ultimately, the thing that people tend to forget is you want to close the project. You want it to end, right? So these are the 4 basic steps, and I'm going to dive through these in a little bit more detail. A couple of them I'll dive into a little deeper. A couple of them I'll kind of skim over because we'll touch them in other places in the talk. So in our case, initiation would be selecting our systems, for example. So initiation typically begins with understanding the requirements that you have for your system. What are your customers' needs? What does leadership actually want you to accomplish? Which then naturally leads you to defining your project, describing the project, and coming up with a scope for the particular project that you're trying to accomplish. This is where the RFI, RFP process typically comes in, the request for proposal, request for information process, which has historically been used to select systems. Now, there's a little controversy nowadays as to whether this is an obsolete or functional process. I'm going to leave that to history and to hallway debates as to whether you need to go through an RFI, RFP process, and I'll talk about it in a little bit more detail as we go forward. The next thing that you're going to do with your project is you need to make a project proposal. You need to establish the business case to your leadership to understand what it is they want you to accomplish, to come up with a budget, and to come up with a rough order of magnitude for what this project actually looks like. This is not the plan yet. This is just sort of scoping out what it is you're trying to accomplish and whether it's even feasible, I guess, is one of the things you're trying to determine. Typically, this then results in what one would describe as a project charter. Now, this is a bit of industry jargon that vendors will typically put in front of you and ask you to sign off that you agree that this is what you're going to do and you're only going to do this and these are the people that you're going to allocate to do it and it's going to take this much time. Everybody signs it and it's immediately obsolete. Okay? But they make you do it. Don't be afraid of it. Sign away. The implications are probably not as deep as the charter itself might expect. But read the contract carefully because there can be some gotchas deep in the project charter. So, for example, if it's a 90-day project and you go to 120 days, is there a cost to you for having not met that project charter? So be careful about your charter. Ultimately, the next phase of this is going to be our project planning process, and this actually overlaps and it is iterative because planning and initiation ultimately inform one another. As you begin to plan, you'll realize, oh geez, we may need a little bit more money for that, or we may need a little bit more money for this, or we're going to take this part of the project out of scope for right now. Another interesting question is, when do you get your capital for a particular project? I've seen projects that actually start with capital already in place for the project before anyone's actually done any planning. And I've also seen projects started with no capital. That doesn't get you very far. If you haven't got any money and you haven't really done a plan, how can you start a project? But in the real world, this is what people do. They want to get something accomplished. So they may start a project before they've even done anything to plan it. Don't let that happen to you. So when a project really starts, in my opinion, is when you get funded, or therefore after, when you've selected your system, and when you've ultimately purchased your system. That's when your project starts. Now, interestingly, sometimes you may stop right there and decide, we're not going to actually do this project for 6 months because we don't have time to do this project right now. But we had the money and we had the need, so we're going to actually pull our money, pay for the project, and put it over here on hold for 6 months and then start to implement that particular project. Ultimately, the project can't start until you have your plan in place. So we'll delve right into planning in a little bit more detail. So these are the basic components of a project plan. A budget, what we call a work breakdown structure, and this is a formal term that's used in project management called WBS, or work breakdown structure, which can ultimately lead to a schedule, and schedules are oftentimes represented in what are referred to as Gantt charts, and we'll talk about that in a little bit more detail. Another way to represent the schedule and the interdependencies between projects are what are called PERT charts, or network diagrams, or logic diagrams, and we'll dive into that in a little bit more detail, as well as looking at what a formal project plan should be. I'll give you a couple of hints or helpful words, I hope, around what you might put into what we will call a project planning packet. So, a project budget. This could probably be an entire hour in and of itself, if not more. By the way, this entire talk could probably be a whole day, which is one of the challenges of putting it together to give you 10,000 feet. But the finance aspects of a project are actually very complicated. But the most important thing to understand is that there are two different budgetary aspects to the financing of a project: the capital needs that procure the large ticket items, the hardware, the software, the licenses that you're going to need, and then the operational aspects of a project which cover different behaviors altogether. So, for example, training is typically able to be financed out of operational funds, whereas procurement of the laboratory information system hardware has to come out of capital funds. And the funding streams for these two different types of financial support are very different in most institutions. So capital and operations is really important to understand in a project, but if you can figure out what's capital and what's operations, you may actually be able to decrease your overall capital costs because there's some things you can pay for with operational dollars that may already be in existence in the institution or within your department. It's also important to think about contingency, and we'll talk about this a couple of times. I noticed I mentioned contingency about 5 times in 5 different slides. That's because I've been burned so many times in project finance that you always want to bake in 10 to 20% of your project to make sure if you come up short, you got a little nest egg that you can dip into and get some more money. And by the way, the institution will never fault you for giving them back the contingency funds for the project that you didn't use. They will fault you for asking for more money because you ran out and you can't complete the project. So don't be afraid to ask for contingency, bake it in, and demand it. Get help. Get mentors who can help you finance projects, and frankly, this is not my world. This is not what I have to do. This is where I work with my vice president of operations in the laboratory, the department of the chairman, and my managers in IT in the laboratory and information systems. They really help me develop the budgets, and I look at them and try to see if I can find any holes in them. So, next step, the work breakdown structure, the components of the project. What are the different steps you're going to do? And really, this came from really a 20th century concept that was developed by Henry Gantt, who lived in the 1860s to the early 20th century. So this is a relatively old concept, but basically the idea is to take all the different components of a project and break them down into as much detail as possible so you know what are the different things you're going to have to do throughout the life cycle of a project. It's basically going to define the work that you're going to have to do, but realize it's not an absolutely complete list. It's really more of a list of the categories of activities that you're going to need to do. Put shoes on, not necessarily getting down to how you actually tie the shoe, although tying the shoe may be part of the project. And so when you do that, you can take a project and you can literally break it down into component plans, and probably most of you in the room have seen either Microsoft Project or some other version of a Gantt chart that shows you all the different WBS elements of a project, what their timelines are, and how those timelines may actually interrelate to one another. And typically, as you can see with the timeline here, this timeline is required for that timeline to begin, but this timeline can happen in parallel with this timeline. So there are actually ways that you can use Gantt charts to represent overlapping and integration of projects. But it doesn't work as well as we'll see with the network diagram. So you may actually, if you have a complex project, need to move to a different representational tool. And by the way, these are tools. These aren't requirements. A spreadsheet with a list of elements, dates, assignments, so forth and so on, could be just as effective as a very complicated Gantt chart or network diagram, in my opinion. So the problem with these charts is that they're oversimplifications. Another problem that's been historically noted is that managers try to design the schedule at the same time that they're figuring out what the WBS is. And if you think about it, that doesn't work out very well. It makes much more sense to define all the components of a project, then try to determine a schedule. But that is almost impossible because reality intervenes and you find that you missed different components and you have to insert things into your project plan. WBS changes as the project changes. So if people insert things into the project, you'll have another work activity that you have to accomplish. And this is what is called scope creep. So if something is going to be interjected into the project that you didn't realize, say for example, your Unix server has found to be not forward compatible with its operating system, you may find yourself having to do a server upgrade in the middle of your project that you didn't plan on. Now that's probably a required bit of scope creep. There are unrequired bits of scope creep that might be driven by customers, and this is something that the project manager has to manage very carefully, or the project gets off timeline. Let's see, final point. One of the problems I've seen with Gantt charts is that there are project managers who seem to spend most of their time working the Gantt chart as opposed to actually working the project. The other thing that's kind of interesting about Gantt charts is you just change the dates and all of a sudden the project's right back on time again. Nothing has slipped. Okay? So beware of that. In fact, one of my techniques is to actually print out the project plans and I save them sequentially. And then I can go back to people and I can say, hey look, this project plan doesn't look like it was when it started. So keep hard copies around because soft copies have a way of being altered. Let's see, components of a project plan, the whole concept of this PERT review, and to me I find this kind of a challenging acronym because it stands for Program Evaluation Review Technique, and as I've wrapped my mind around those words over and over again, they're starting to make more sense to me. But this is a technology or technique that's used in project management that helps you understand how tasks interrelate to one another. So rather than just being like a Gantt chart where you have a schedule and a sequence, a PERT chart can actually give you a better representation of the flow of a project and how components of a project interrelate to one another. And this typically fits with a style of project management or a project management approach, which is called the critical path methodology. And this is a technique that's used to help determine what is the minimum time that it will require you to get a project accomplished, as opposed to the way your Gantt chart works, where you sort of just create a schedule and say, well, we think we'll do it like this. Not all projects need a PERT chart, but if you've got a very complex project that has got a lot of parallel steps and things that are required for different teams to accomplish before you can get to the next step, it probably makes sense to represent it in a PERT chart. So this is what a PERT chart actually looks like. So we've got a project, and we've got a 7-month project, and we've got 5 different milestones, which is what these circles are, and 6 different activities, A, B, C, D, E, and F. And if we look at this, if we went from 10 to 50, notice that's only 3 months. But we actually have got 2 activities, one on the top and one on the bottom, that are going to take 4 months and 3 months each. So therefore, the total time for this project is actually going to be 7 months. Now, if this top line, for example, had this step here took 2 months, so therefore the project would be a total of 8 months, this would be known as the critical path, because that would be the minimal amount of time that it would require you to do a project. Okay? Very formal terminology for a relatively simple concept. Rate-limiting step, I guess, would be the way to think about it. Let's go to the next idea. So one of the things that I found is really helpful in project management is to put an entire packet together that gathers this information and keeps it in such a way that it's easy to update, easy to keep linked to people and be able to distribute it. And so we actually use a template, and actually it's just based on a simple Excel spreadsheet that we have multiple tabs on that include a narrative description, our budget, who our team members are, what the schedule is going to be, tracking of issues that develop in the project, which allows you to not only track the issues, but close the issues, prioritize the issues, assign the issues, determines the training. We actually use a page in that document that links to all of the supporting documentation that was required for the project, so the project charter, the project plan itself, maybe another formal budget, training manuals, user manuals, and guides, because all of this documentation tends to get lost over time. So how do you pull it all back together so you can find it? So we found that this is really very useful. And then ultimately, something even as simple as an activation plan goes into our template. We have actually implemented this over the last 3 or 4 years, and it has been a lifesaver to many of our projects. And it's very standardized, so every member of our team now is required to do at least one project over the course of the year, and every one of those projects must use this template, and this is actually one of the ways that we assess them. So, project planning, 10,000-foot view. Project execution, the next phase. So when we talk about execution, we're really talking about getting the work done, okay? So we're going to contract, and that's really when our project is going to kick off. And then what we're going to do from there on is we're going to evaluate, we're going to follow changes, we're going to issue status reports, we're going to follow our project plan, and we're going to update our project plan, because project plans are not static. They actually change over the course of a project. So really, if you think about all that, it's mainly about communication. It's about planning, scheduling, planning and scheduling and working. The task is actually relatively easy. This is what people do the job for. They enjoy working the tasks. It's the communication between the teams working the task that's the real challenge. Because if communication fails, so will the project. Every time. Communication blows up, project is dead. So that's, to me, really what a project manager is doing for most of their effort, is making sure that we've got a good communication structure, and I'm going to talk about that a little bit more. Aspects of execution should be captured using documents, including things like meeting minutes and updates to the project plan. These need to be assignments that people actually have as jobs. Think about your training early on in your execution part of your project. And I'm going to bring that back when we get down to some more of the practical issues, because that becomes a very practical part of doing a project. So on to the last phase of project planning, project closure. And by the way, many of these concepts, by the way, are taken out of the Pathology Informatics textbook, which has a really nice section, very simple section on project planning. One of the few informatics textbooks that I've seen that actually addressed this management issue. So we looked at the idea of project closure, and ultimately you need to follow what's remaining as you get down to the end of the project. There's always going to be things hanging that you need to get accomplished, or you may even decide we're going to take that off the table because we don't need that to go live on our particular project, so we're going to delay it. Training is really important to remember. People tend to forget training, and many projects fail due to poor training plans. They may have training as a bullet item in their project plan, but people often don't think about the level of detail that users require for training. And this is very typical of large EMR projects, by the way. I think we probably all see that. I see a lot of heads nodding out there. Remember the launch of a project. A lot of people forget that the launch, the day you go live, requires different behaviors in different cadres of people to help support what you're going to accomplish. You need to establish a command and control center and have some sort of a communications plan, potentially even a backout strategy. God forbid. But it's true. You have to plan for failure. If you don't, you're going to. Another, I think, important part of project closure is summation to leadership. You need to be able to learn from projects, and leadership should ask you to tell them what you have learned from projects, and you probably should do that relatively formally. Another aspect of summation to me is reward. Reward for team members and reward for our customers. There should be a celebration when you achieve a project, okay? But oftentimes what happens is we're done and everybody just wants to go home and go to bed. Plan a celebration. Plan something formal that you're going to do to recognize the folks in the project. And that can be a very simple thing. Balloons in the laboratory, a pizza party in the lounge. There's all sorts of things you can do to reward people for the pain and suffering of having gone through a project. All right, where am I for time? 34, we're going to noon, right? So I got about 25 minutes, so I'm right on target. So what I'm going to try to do now is to take some real-world experiences that I really haven't gotten into in detail and kind of reapply them over that more formalized approach to project planning. So the first part was kind of the didactic, this is the dirty laundry. Oops. Hello, come back. I'm not going to spend a lot of time on RFI, RFP process, but I want to make sure I use the words for those of you in the audience who have not been exposed to this. The idea is when you're going to select a system like an LIS, the first thing you're typically going to do is ask a bunch of people who have got one to sell you, what have they got? And are they interested in selling you one? Because some vendors will not be interested in actually selling you their system. So you send an RFI out, a bunch of people will say, hey, great, we'd love to work with you, but some people may come back saying, no, our LIS really isn't a good fit for you. So this is sort of like a pre-step for doing your LIS implementation. And I list here some of the things that you might want to look for in an RFI. I'm not going to say them all, but the goal is to eliminate somewhere around all but 3 of those particular vendors that might fit you, because then what you're going to do is you're going to go back to those vendors and you're going to ask them for a very detailed RFP, a request for proposal, where you're going to ask them for a very detailed set of specifications around their project, and potentially even to start to do things like on-site demos, and it's absolutely required to talk to their current clients and get out and actually talk to people who are using that particular system. So this is the concept of the RFIP process, but this is the problem. We think we know what we want, but actually we don't know what we want because it hasn't come around yet, but it will come and then we will want it. So it's really important to realize that even though you've got a good project plan, you think you know what your requirements are, requirements change as time goes on. There was no requirement to have your LIS work on an iPad 5 years ago. There was no iPad. One of the best ways, I think, to do this is to actually create a process and to use this as a team-building exercise. Because if you can get people involved very early on in the system selection, these ultimately become the same people that you can use to help you implement your project. And I'm going to hammer that out a little bit more. So these are the folks that can tell you what they need, determine who the key stakeholders are and what level of the organization you're going to pick these people from. By the way, in my opinion, a selection team is typically deeper than an implementation team. You want a much broader representation of knowledge from a selection team than you might necessarily need with an implementation team, because you're trying to make sure that you ferret out all the needs that you're ultimately going to require. Now, interestingly, I say, how long do you want to take? Well, what do you mean, how long do you want to take? We're going to do whatever it takes to get the project done. Wrong. If you try to get everything done with the first phase of your project, the first pass, you will never finish, and therefore it will never be really a project. It will be an ongoing dilemma and nightmare for you, because the process really is never complete. Once you get your first phase implemented in your project, the system's, in theory, going to continue to grow and evolve and be updated, so forth and so on. So think about what it is that you really want to do in the first phase of your project, and also take this as an opportunity to educate the people that you're going to involve, because this is a great way to really get those folks on board and educated. Another way to look at this is to think about what we call functional needs or operational needs. So functional needs allows you to create this thing that's called a needs analysis. But the operational needs may look at things more like workflow or what services you need to accomplish, like do you have an outreach program that you're trying to implement? Think about what your performance needs are. How many users are going to be using the system? How many institutions are going to be on the system? What's the geography and distribution of where these people are actually working from? These all have important implications on the project, as does your IT environment. You can either look at this as a feature-driven approach, which is going to resonate with users, or a technology-driven approach, which may fit better into your particular environment. And I'll bring some caveats on that in a few slides. One of the ways to accomplish this is to use what's called a SWOT analysis. So this is another kind of buzzword term that I want to make sure you all hear at least once. But the idea is that we've got the ability to analyze the strength, the weakness, the opportunities, in other words, new things that we'll be able to leverage, as well as threats in our project. So you can see where SWOT comes from. But this type of approach is really pretty generic, and it allows you to kind of get to the dirty laundry that a system implementation might have, say, for your microbiology laboratory. Make sure you get with users outside your selection team meeting. Go and see, walk around, ask questions of people as they're using their current system or doing their current work, and try to build this into some sort of a SWOT analysis. And then make sure you come back and share this information with other key members. So we think about what the key factors might be. Obviously, your system functionality, scalability, cost, synergy with other IT systems, how are we going to interact with other vendor systems, what the support and maintenance costs and human resource requirements are going to be. But don't forget about vendor stability, because picking a vendor who's not going to be there tomorrow doesn't ever result in a good project, and this happens to us. The challenge really is we don't really know what our needs are, and oftentimes we don't even know what our workflow is in the laboratory. So this is a good time to try to ferret out what the current practices are, what are bad practices that are really due to workarounds, and typically this isn't done. People kind of run off with the wheelbarrow, say, oh, by the way, you know, here's your pound of sand, and they say, well, I wanted black sand, not white sand. So pay attention to this, get people involved. Technophobia is a very big challenge in implementing IT system projects. So getting people involved, getting into their laboratories, getting their hands on the system early on, showing them demos can really beat this down. And interestingly, the system is often blamed for poor operations and poor workflow design, which is not the case. That's all about implementation. So get those users involved. So some general issues, if we think about the lab environment, I'm not going to read through every one of these, but obviously every one of these items determines what you have to look for a system. If you've got a multi-institutional system that you're trying to implement an LIS across, you've got a different requirement than a standalone community hospital. Think about billing, and think about your support team, and don't ever forget about your user sophistication. Your IT environment is a very important part of standing up a system. It needs to be reflected in your plan. Do you have centralized IT, or are you hosting it in your own laboratory, or are you using some sort of an application service provider? Make sure you've got the appropriate expertise in the different components of your project. And then the other thing is clinical pathology system selections have some unique attributes that are different from AP systems, including, does my LIS actually interface to my vendors and my interfaces? Do I have the ability to support all of the areas of the laboratory with a system that I'm selecting, or am I going to need a separate system, say, for blood banking? Is it your current vendor? Make sure that you look at your current vendor and make sure that they are able to support what your current needs are. And I've already alluded to users and locations, so I won't beat that in any more detail. With AP, things become a little bit more different. So, for example, data conversion is a big problem in AP systems implementations because you need all of the historical data from the AP system. This is typically not as an important requirement for clinical pathology lab systems. This is a big part, by the way, of any AP systems implementation that I've ever had to lead. There are interfaces in AP, so think about them up front. There are interfaces now to automated stainers. There will be interfaces to imaging systems. So think about them as you're planning your AP project. Do you need to support outreach or imaging, as I'm just alluding to? So these were designed actually to be a series of things that you can take back with you, look down them, and use them as a checklist in your needs analysis plan. So here's where the fun begins, because in my opinion, this is what makes project work, is getting a formal team to participate in your system selection. Make sure that there's going to be some overlap with the implementation team, but it should be a broader team and there should be more of a diversity of opinion. Make sure you think about who you would want to involve in implementation. In fact, getting a good selection team can be a really good hint as to who might be helpful as you're doing your system and implementation. So it's almost like an interview for participating on the implementation team. And you'll find actually there will be people who help you select the system who are excited about being involved in the implementation, and you want to figure out ways to grab those folks. Look for participants that can marshal your end users. So find that person who works in the microbiology lab, who's very enthusiastic about using IT and is interested in getting ideas from other people. And the thing that I've always found most difficult, but I always try to force myself to do it, is find some people who are really Luddites, the naysayers. This will never work. Because when you win them over, your project will never fail. They will be the champion ultimately. So I've always believed in trying to recruit the naysayers. It can be painful because they're just grumpy. You know, it's that's all. I'll just leave it there. Get this team involved at the beginning of the process. Don't wait until you're 3/4 of the way done and say, well, I think we better go out to the selection team and see what they think about what we've already decided to do to them. Get them involved early on. And why don't we do that? We don't do that because it's painful. It takes a lot more effort. There's a lot more opinion. But that's what you want at the level of the selection. It pays off at the implementation every time. Capturing the work. This is another really big challenge in any project, because if you do all these meetings and you create all these documents and they go off into the ether or a whole bunch of email threads, you really can't use that information to go back and look at how you made design choices, so forth and so on. So make sure you capture the work. Processes are relevant as data is not captured. Get administrative support. So tell leadership you're going to need someone to take notes, be a scribe, whatever you want to call it, and make sure you plan to schedule those meetings and communicate the status of those particular meetings. Use spreadsheets, word processing documents, PowerPoints. Put it online for easy communication. In fact, we're doing an Epic implementation right now, and one thing the team has really done a great job at is they built a fantastic website that actually captures everything that's going on in the implementation project. Use this as a way to educate your team. So use it as a way to take them through the technology, talk to them about servers and databases. Yeah, their eyes will gloss over for a little bit, but then they'll be really proud that they know what a Unix server is. Use it as a way to raise the floor on computing in your site environment. And get those folks involved in coming out to the demos and site visits, because this is something that's different from their everyday work, and it really creates enthusiasm amongst your team. Scheduling the meetings. Favorite thing we all love to do is sit in meetings. But you got to have meetings if you're going to do a project. In my opinion, the key is to schedule them formally, and adhere to the schedule. Canceling meetings sends a message. Have a short meeting, but don't cancel the meeting. If you cancel the meeting every other week, the third week, you're not going to have anybody show up to your meeting. So be aware of saying, well, you know, we really don't need to meet this week. Find something to meet about. I'm not saying waste time, but make sure you stay on schedule. And then ultimately, over-communicate the issues that you're involved with. Make sure everybody knows what the charge is. Make sure everybody knows where we are in the process of implementing the project and what's going to happen next. What have we accomplished? Time is always going to be a problem for these folks because they're trying to change a tire on a moving car. That's kind of hard to do. It reminds me of like a Bugs Bunny cartoon. But that's something, then what do? People are working and you're not doing a system implementation. Who? Get the chairman involved. Even if it's just to come down and go, rah, rah, go team. Get the chairman involved. It sends a big message. Get your pathologists involved. They don't want to be involved. They're busy. I've got better things to do. No. If you want a better AP system, get involved with the implementation. And make it worth their while to get involved. Put them in charge of something. And that includes everybody else in your team, as well as your IT team. And then the only other point I'll make about the team is to watch out for becoming too top-heavy. If you got too many people who are chiefs and you got too few people who are Indians, you don't have enough people to actually get involved with doing the work. So make sure you involve people who are going to be using the system daily, who are currently using the system daily, and bring them into the process. Consultants, the dirty word, not in my opinion. Consultants can be invaluable. If you pick the right consultant, you will potentially have a much smoother system implementation. Yes, the wrong consultant can hurt you, but consultants can be very helpful. They can save you a lot of time and money. They can keep you on track, and they can help you gathering that data that I was talking about earlier on. There are valuable expert consultants that are out there, and don't look at it as an embarrassment to say that I need help because we don't have expertise in our team. Plan who's going to have the final say in the selection. This is another really interesting conundrum that I've seen happen over and over again. You do all this stuff, you gathered all this information, but no one has ever decided formally who gets to say yay or nay. This is where democracy sort of ends. So plan for this in advance. Plan how you're going to actually look at these systems. You can get really anal about this using rank order lists and weights of features and so forth and so on. But, in the end, have a plan is all I'm going to tell you right now. I'm going to tell you how to do that. So why do these things fail? Flawed selection process, according to Mr. Braley, one of our better-known consultants in this industry. Poor planning and communication, wrong people involved. Interesting, wrong people involved can be too few or too many. So it's one of these double-edged sword things. It's really the right people that you need to get involved. And then interestingly, one of the big challenges that I've seen with system implementations is lack of alignment with institutional goals. And I'll spend a fair amount of time looking at that as we go forward to the next phase. Another time check. Good. Right on target. Amazing. You put these slides in here and you say, well, how am I going to get those times? I should almost have timers or timings, but I can't do that. So institutional planning, if you ain't got the do, re, mi. Does anybody know that Earl Guthrie song? He's basically saying if you can't sing and you can't play, you can't be in the band. And what I'm alluding to here is if you're trying to do A and the institution wants you to do Z, you're very likely to fail at what you're trying to do in your project plan or your project implementation. Your justification for capital, based on your SWOT analysis, is a really important part of institutional planning. Get that information out to your IT budget, to your chairman, and begin to lobby your CEO to make that project work. That's when you're going to find out that you are aligned with what the institution wants to accomplish. So a lab may think they want to do an LIS implementation, and the institution may be thinking about replacing their EMR that has its own LIS. Interesting current conundrum. Make sure that you've got a way to lobby for this capital. No money, no LIS. The idea of who has the budget also becomes an interesting conundrum for us to deal with. So if your budget is part of the IT group, IT may be the person selecting your laboratory information system for you, and that may just be the way it is. Well, that doesn't mean you're dead in the water. It may not be a good thing, but get lab onto that team, or better yet, get IT onto your team so they can see that you know what you're doing, because if they don't have to manage the project, they'll be very happy to have somebody else do the work. They've got plenty to do. If IT is going to lead the process I already alluded to, make sure you have a leadership role on that particular team. Budget. Again, I've alluded to budget a couple of times. One of the problems with budgeting is that you may actually have to submit a request for a budget before you actually know what it is that you need, so it can be really challenging to figure out in a rough order of magnitude what the actual budget request you want to use. There are ways that you can request this, and this RFQ stands for Request for Quotation. I've never really seen that do anything to mitigate falling short in budget, because you don't know any more from the vendor side giving you a number than you know from your own side. Plan to revise your budget as you go forward and build in contingency money, and I've already alluded to this again, contingency, 10 to 20%. One of the challenges, by the way, with contingency is if you've got a $10 million project and you're going to build in 20% contingency, that's a pretty big chunk of change. So people are going to kind of look and say, what are you talking about? It's a $10 million project. Why do you need 12? Ask for it. Give it back. Well, let's see. Institutional planning. And basically, this is just a list of all the things that I have seen happen that actually run into projects that I'm trying to accomplish. One of the biggest ones has been EMR builds. We're trying to do our work in our lab. The institution decides they're going to do an EMR, and boom, all of a sudden, any IT resources to help you with your LIS implementation are now gone. This happens over and over again, and I'm sure in the room there are many people who have seen that very recently, because there are a lot of big EMR implementations. Purchases of new hospitals. Seen that 3 or 4 times now. We're building an LAS, somebody goes and buys a new hospital. Expansion of clinical services, things that didn't exist, creating new centers of excellence. All these things drain capital to these worthy projects. You need to know what's coming down the pike. So make sure you're asking. That doesn't mean it's going to happen. It's not going to happen to you. And I have a rule of 5, and that is, I think every year there will be 5 big projects. I'm not talking little things, but 5 big projects that no one has announced to us that they're going to come to lab and say, by the way, we need you to do this. We always get it done, but there will be 5. In fact, so far this year, there have been 4. I'm still waiting for the 5th. The last one was build this tissue repository that will have every tissue in the world, and we'll just have it, and it will be de-identified and HIPAA compliant. Oh, that's a brilliant idea. I don't think we'll be able to do that this year. Look at process improvement, my point is, process improvement is wonderful, but process improvement can be the tail that wags the dog. Sometimes process improvement consumes resources that don't allow you to accomplish your process. And interestingly, sometimes all these happen all at the same time. So it's like a perfect storm. So be aware of these institution-wide projects. If you don't, you will come up short. The project will take longer than hoped for, but the bottom line is it's probably going to happen to you. So accept the fact that it's going to happen to you, and you'll be wiser for it. And what I like to say, and my manager likes to say this all the time, no one remembers a system coming up late. They always remember a system coming up badly. Okay? Better late than bad. So make sure you do a good job. All right, some conclusions and practical concerns. I've already talked about a lot of these details right now, but these are the types of advanced functionality that people will ultimately kind of throw at you. They'll lob them as sort of hand grenades. Well, how do we get to the LIS with the web portal? I'm not going to belabor them. Application features really resonate with users, but application features may not necessarily have the right technical underpinnings to make them valuable to the institution going forward. The whole concept of vendor selection around best of breed versus single vendor, we're going to be talking about all afternoon if you have any interest. Think about your historical relationships with a vendor in the whole idea of upgrading versus replacing your laboratory information system. I think I've hit most of these details on budgets, but I laid this out here very clearly so that you've got a pretty good tick list that you can go down as you're looking at the budgetary concerns that you should think about. And I think I hit almost every one of these things. I didn't talk a lot about the human resources down to the level of training and subject matter experts, but it's important that you carve those people out into your project and make sure you have them identified early on, or training is not going to be effective. The most important point on this slide is the bottom bullet point, and that is that time and your human resources are your most precious commodity. It's not the money and it's not the technology. It's the people and the time. So that's what you manage to have a successful project. Your workflow design and system implementation outweigh any single application feature, in my opinion. So application features change, right? Version 5 has more than version 4, which had more than version 3. But if you can design and implement the system effectively in terms of workflow, you will be able to evolve with each of the new system features that you have. Users have to define the workflow. So that means you have to go to users and say, how do you do this now? How would you do this with your new system? And this can be a very challenging thing to ask. Look for champions in each of the lab areas, train them, prioritize their ideas, and address them over time. But also set the expectation that they may not have the perfect ship on day one. They likely will have one that floats and moves. Test, 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 and test some more. My favorite thing. If you test well, you will go live well. If you test poorly, you will be bitten over and over again by things you miss. So testing can't be underestimated. And interestingly, users have to do the testing. This becomes a very challenging thing in any system implementation I've ever seen. So figure out a way that you're going to get the users to do the testing, document that they did the testing, and then get help from above to make sure they have time to actually do the testing required to assess your system. And don't forget to plan for updates. Updates, upgrades, and new systems will get you every time. In fact, the last LIS implementation we did, halfway in, there was a big update that was created by the vendor for that system. And we couldn't go forward with our implementation until we decided how to implement that update. It became critical, actually, for the system to be implemented, and it cost us 6 months. But we had to go through it. Our landscape isn't stable. Don't expect it to be stable. Ask the questions, look around for these things, try to get into the know of people who know whether an update is going to come down the line. We actually tend to do this pretty thoroughly in terms of our testing. The same is not necessarily true with other types of systems being implemented. New systems require new resources. Oh yeah, we always get that. New system, 5 more modules, 2 more hospitals, we're going to give you 5 more people. No. You're going to have the same people, but think about it. How are you going to resource the new attributes to your system? I think this is the final slide. Trying to automate too much at once is a key mistake. Weighing internal lab features too high over core system technologies. Features change, technology rides with you for the future. Weighting order entry and reporting too low. This is an important thing that people miss. Not planning enough time and not involving all system users in advance. I think I've beat that point to a very thin gold veneer. Get the users involved. What's the last slide? So here we go, the end. Thank you all. By the way, this is the view from the top of Croagh Patrick in County Mayo in Ireland. Questions?
Are there any questions for Dr. Tuthill?
What's for lunch?
All right, so you have an hour and a half for lunch. Please be back in this room at 1:30. We will get started promptly. AV technical issues accommodated.
Thank you. Thank you for forcing me to figure out how to do this in an hour. Thank you for forcing me how to work this. I delivered it in an hour. Thank you. I learned a lot.